So after reading this question, we see that we're going to be concerning ourselves with kinetic energy. So we're going to approach the problem using the law of conservation of energy. So at the top of the hill, we have gravitational potential energy, GPE. At the bottom of the hill, we have two different types of kinetic energy. We'll have kinetic energy translational, and we will have kinetic energy rotational. And both of those have to combine together to equal the initial energy. So we'll substitute some numbers, some letters in here, equations. mgh equals 1/2 mv squared. Both of those come from a previous chapter. And then our kinetic energy rotational will be plus 1/2 I omega squared. So we can substitute in for I and for omega as well. So let's do that. mgh equals 1/2 mv squared plus 1/2 I will be 2/5 m r squared, and then omega will be v divided by r squared, coming from the equation that v equals omega r. And rearranging that, we can get this. So looking at this particular equation, we see that all the terms have an m, so we can divide all the m's out. This r squared and that r squared will cancel out, and this 2 and that 2 will cancel out, giving us an equation at the end, gh equals 1/2 v squared plus 1/5 v squared. So now what we can do is we can simplify this and put some numbers in. So g will be 9.8, that's our gravity. The height, if we draw a triangle over here just to make sure we understand what we've got here, this is our height over here. That's our 30 degrees, and this is 10 meters. So the height will equal 10 sine of 30 will equal 7/10 v squared, because 1/2 and 1/5 is 7/10. So if we solve that, we will get v equals 8.37 meters per second. Now we convert that back again using this same equation up here. We can then get that omega will equal 41.8 radians per second. So that is our two values for part A. So now we're going to go on to part B. Now part B asks us to find the ratio of the kinetic energies without using any numbers. So we'll start with our kinetic energy of translational, KET, and we'll compare that to our KE rotational. So we'll put our equations in here, 1/2 mv squared divided by, and our equation for the rotational will be 1/2 times 2/5 m r squared times v squared v over r squared. And again, we're going to simplify as best we can, so we can cancel out a few things here. We can cancel out this 1/2 and that 1/2. We can cancel out m and m. We can cancel out this r squared and that r squared. And we can cancel out v squared and v squared. So this becomes 1/2. Well, that's a complex fraction, so we can change it over, invert and multiply. So I get 5/2, which becomes 2.5 to 1. And that is our ratio of the two kinetic energies.